Right. So this video for week 7 will cover sections 4.7, 4.8, and 4.9. And so we have, first off, in terms of dealing with everybody's favorite topic, word problems. So optimization problems, so this comes out of the book. Basically the steps in terms of solving the problem. So understand the problem, draw a picture, notation, and then come up with the equations and solve it. So we'll look at this in terms of a problem. So for example, this one. Farmer has 2,400 feet of fencing, wants to fence off an area that borders a river, no fence along the river. What are the dimensions of the fence? So we have our river, and then we want to have a fence bordering the river. Okay. So we don't know what the dimensions are, so let's call this x, and this will be x, and then this will be y. Okay. So we know that there's 2,400 feet of fencing, so we know that 2x plus y has to equal 2,400. We also know we want to maximize the area, and area of a rectangle is given by x times y. Okay. Well, this is what we want to maximize, but we have this equation is in terms of two variables. So we need to make it in terms of one variable. And so we're going to take our perimeter equation and solve it, in this case, for y. So subtract 2x. And so y is going to be 2,400 minus 2x. So now we can take this and we can plug it in for y over here. And so now our area equation will be in terms of only one variable. So it'll be x times 2,400 minus 2x. And this will give us 2,400x minus 2x squared. The next thing we want to do is we want to take the derivative, and so the derivative of the area with respect to x, and that'll give us 2,400 minus 4x. We then take that and we're going to set it equal to 0. And now we want to solve this for x. So we'll bring the 4x to the other side. And so 2,400 is equal to 4x. Opposite of multiplying is to divide. So we divide by 4. And we get that x is going to be 600. Well, we know y is given by our equation, which was 2,400 minus 2x. And so y will be 2,400 minus 2 times 600. And this will give us 1,200. And we get our dimensions of our fencing. So let's look at another example. And so here we have now, we got 1,200 square centimeters of material. Make a box, square base, open top, find the largest volume possible. So in this case, we have a square base. So this will be x by x, and we have a box. Okay. And we'll call this y. Okay. Okay. So in terms of volume of a box, our volume is going to be x times y The amount of material we use, well, it'll be the base. And so that'll be x squared. And then each of the sides, the area is xy. So plus 4xy. And that equals 1200. So now we want to take this equation, we want to solve it for one of our variables, and then be able to plug it into our volume equation. So if I look at this, I can factor out an x. So this will be x. Let's not do that, sorry. We're going to solve this for our y. So we're going to subtract x squared. So we get 4xy is going to equal 1200 minus x squared. Okay. Again, we want to solve for y, so the opposite of multiplying is to divide. So we're going to divide by 4x. Divide this by 4x. So y is going to be 1200 minus x squared over 4x. So now we're going to take this and we're going to plug it into our volume equation. So we had v was equal to x squared y. We had y was 1200 minus x squared over 4x. So v is going to equal x squared times 1200 minus x squared over 4x. So now if I look in terms of this, well, we got an x down here, we got an x squared up there. And so this x goes away, and this will just become x to the first. And so we'll get 1200x minus x cubed over 4. We can also re-look at this and simplify this a little bit. This is the same thing as saying 1200x over 4 minus x cubed over 4. So this will be 300x minus x cubed over 4 is volume. Now again, we want to take our derivative. So we're going to take the derivative with respect to x. So dv dx. This will be 300. And this will give us 3/4 x squared. We then want to take that and set this equal to 0. And so let's bring the x squared over. So add 3/4 x squared. Add 3/4 x squared. So 300 equals 3/4 x squared. We then want to get rid of the 3/4. So divide by 3/4. Divide this by 3/4. And so we get 400 equals x squared. Opposite of squaring is to take the square root. So x is going to be the square root of 400. And x will come out to be 20. Right? So now that we know what x is, we can get our value of y. And so y is going to be 1200 minus 20 squared over 4 times 20. And we end up, this will come up to be 100. So you have in terms of optimization problems. The next section, section 4.8, deals with a thing called Newton's method. And really this is a calculator exercise. So we want to find the approximate root. Now again, this is back in the days of Newton where you did not have a calculator or your computer that you could just plug it in. You had to figure this out by hand. So find the approximate, this should be find the approximate root. Okay. So for example, we have this equation, x cubed plus 2x minus 4 equals 0. Okay. And we want to solve this for x. Our first guess at the answer is 1. Right? Now if I plug in 1, this will be 1 plus 2 is 3. 3 minus 4, well, it's not 0. Right? But the method calls that your x guess, so x of n plus 1, is your previous guess minus the function evaluated at that number by the derivative at that number. Okay? So let's look at this problem in terms of that. Well, my f of x is going to be what we have here. F of x is x cubed plus 2x minus 4. My derivative of this is 3x squared plus 2. So this says then that x sub 2 is x sub 1, which was 1, minus my function evaluated at 1. So 1 cubed plus 2 times 1 minus 4 over the derivative evaluated. And so this is going to be 3 times 1. So we plug this in, and this is going to be x sub 2 is going to equal 1 minus, we said this is going to come out to be minus 1 over 3. And so it'll be minus a minus, so it becomes a plus. So this is going to be basically 1.33 and change. Right? Well, then the method says, okay, then you go and say, okay, x sub 3 is going to be this number minus 1.33 squared 2 times 1.33 minus 4 over 3 times 1.33 squared. And that would give us our next number. And then we can keep this process going for however long we want, to depending on how many decimal places we want our answer to. Right? So the last section for today is they call anti-derivatives. So we've been taking derivatives, and now we're going to start working in the other direction. Right? So if the derivative, for example, is 2x, the question then is, what was the original? So what was f of x? Okay. Well, there are several possibilities. Well, f of x could have been x squared, so that would give me that derivative. F of x could have been x squared minus 5. That would also give me that for that derivative. F of x could have been x squared plus 2 thirds. And that would still give me that derivative. Right? So all of these would all have that same derivative. So how do we find this? So given that we have ax to the n, and we want to find the antiderivative, the way we do this is we're going to have ax to the n plus 1 over n plus 1. And really this is the opposite of what we did when we were finding our derivatives. So when we did derivatives, we subtracted one from the exponent and multiplied. Now we're adding one to the exponent and we're dividing. Okay. So for example, if we had 5x cubed, okay, then this would become 5x to the fourth over 4. So let's look at a few examples of this. So the derivative, actually let's change the page. So my derivative is going to be 12x squared plus 6x minus 4. So we're going to get 12x cubed over 3. This will give us 6x squared over 2. And now here, when we do a constant, we're going to introduce the variable. Right? And as we saw before, we said here, any of these were possibilities. Well, the way we get around that here is we now say that this is going to be plus c, where c is some constant, whatever that might be. And then we can simplify this, so we get 4x cubed, 3x squared minus 4x plus c. And we have our derivative. Let's do another one. So find again the original f of x given. So now we're going to start with the second derivative being 6x plus 12x squared. And if I do the antiderivative of that, we end up at the first derivative. So this is going to be 6x squared over 2, 12x cubed over 3, plus c. But then this can be simplified. 3x squared plus 4x cubed plus c. And now I want to do this again because I want to get the original. And so I do this one more time. And so now we get 3x cubed over 3. Actually, sorry, this should be a 3 here, not a 2. this is going to be 4x to the fourth over 4 plus cx plus d. And so we simplify this, we get x cubed plus x to the fourth plus cx plus d. And we have our a couple other examples. So our derivative is 2e to the t 3 sine t. And again, we want to find the original. So f of t. And so we got for this is going to give us 2e to the t. And then the antiderivative of sine is negative cosine. And we end up with that. And then one last one. And given that the derivative is x squared plus 4x plus 8 to the fifth power times 2x plus 4. So this one, we're going to solve this by doing a bit of thing called substitution. So we're going to have u is going to be x squared plus 4x plus 8. The derivative of this, du, is 2x plus 4. And so we can substitute now and say that this is going to be u to the fifth to u. So now this matches my basic form. So now we can do our basic deal here, and so we get f of u is going to be u to the 6 over 6 plus c. The next step is to substitute back in, and so we get x squared plus 4x plus 8 to the 6th power over 6 plus c. And with that, that will conclude this video.